Hi. Before we start disassembling the application, there are some stuff we would like to find out about this program, the server.exe. You could do all these things what we are going to do with various other commands in Linux. But I wanted to show you how you can do all this in Radari 2. So let's start Radari, R2, server.exe, and we get our command prompt. And before we forget, let's do the analysis, AAA. And now just to show you how intuitive Radari is, what do you think is the command to get information about the binary? You were probably right, it's the command I. So let's do command I question mark to get all the help we need. So it says here, I get info from open file, and then there are a bunch of subcommands. Just to try out a few, we can do IA, I capital A for looking at the architecture. It's a 32-bit x86. Radari supports quite a lot of different architectures, so it could be ARM, MIPS, 64-bit architectures, whatever. This one is a simple 32-bit x86 program. Something which could be usually useful in reversing is to look at the imported libraries. So these are all the imported functions that are used: string copy, string compare, fopen, listen, socket. So the reason why it makes sense to look at this is, you can get an idea of what the application could do. So for instance, from the fact that it uses socket and listen, that will tell you that it probably connects to the network. We already figured it out at the beginning when we started the application, and it did connect to the network. But in some cases, you will not be able to execute the application, maybe because it's a different architecture. Like on this Linux, I wouldn't be able to run MIPS binaries. And in that case, we would only rely on the binary reversing instead of, active debugging. So from here, we would know that it's going to open some ports and listen on that port. Probably it also opens some files, and there is also reading input from somewhere. So these are just ideas what you could note for yourself about what the program might do when it's running. If you just type I without any additional parameters, then you get all the information about the binary. I'm not going to go through the whole thing. There's a file name, format, etc. But if you don't want to look at all the information, you can also grep for something you're interested in. Grep is the tilde character. So when I say grep, I mean the grep command from the Linux command line, which is basically searching for a string in a file or in an input. So we can also search in a string in basically everything in Radari. Whatever command you use and it returns strings, then you can grep it with the tilde character, and that way you can search in it. So we are going to use the tilde to search in the output of the I command, and we're going to look for canary, and that's going to tell us that the canary is false. That refers to the stack canary binary protection scheme, where you use canaries on the stack to see when somebody tries to overflow your stack. If you don't know what's that, I recommend you to Google it. It's a really interesting protection feature for binaries, so you should check it out. But basically, with the I tilde canary, we printed out these strings, and we just searched for the string canary in it, and it returned us just that line. Something which we already know, but you could look for it, is whether it's stripped, and we know that it's not stripped. We know that from when we executed the file command. So that's what I meant. So for instance, if we go to another tab and we say file server.exe, it tells us that it's not strip. So that's what I meant, that we can figure out all these information using other tools, but Rotary will give that for us for free. So there's no need for the other tools. Now, another thing which is really important is the IZ, which says strings in the data section. That basically means the strings which appear when you run the application. So strings for the user usually. So that always makes sense to look for. You can look for error messages you see in the application, or you can look for something the application prints out in a specific case what you want to analyze. We are going to use this later on to try to bypass the login. So if I say IZ, then it says that there are lots of strings. So let's print it. So as you could see, this wasn't right away useful for us because there are too many false positives. So these are probably not too interesting for us. These are the strings, or which were considered strings. It also tells us what encoding that could be. As you could see, in this case, just printing out the strings wasn't really interesting. We could fine-tune it a little bit, but we're gonna use other method later on. I just wanted to show you how you can print strings. If you wanted to, you could also search in the strings with the tilde, but we don't really know yet what to search for, so there is no sense to do it right now, but we will see that later on. As a homework, you could look through all this information. If there is something you don't really know what that means, I recommend you to Google it. These are all important things regarding binaries, so it makes sense to look them up. And when you're ready with that, I will see you in the next lecture. Bye.